Hello and welcome to Tribe Topper. In this video session, you are going to learn about Kirchhoff's laws. Kirchhoff's first law, also called the current law, states that the current flowing into a junction must be equal to the current flowing out of it. So, we often consider it to be a consequence of charge conservation. That means whatever was the total charge before any event, the total charge after the event also has to be the same. So we say whatever amount of current enters, the same amount of current will leave the junction. Now, as you can see here, we have the arrows I1, I2, and I3 pointing towards the junction. So these are the three currents entering the junction. So we'll say I1 plus I2 plus I3. This has to be equal to the other two, the sum of the other two which are leaving the junction. That's I4 plus I5. And you might have seen this. We often apply this when we talk about the current, how it gets divided when the resistors are connected in series. Like if you have two resistors in series, R1, in parallel, R1 and R2. So when the two resistors are in parallel, the current that enters here is I. It gets splits up into two parts, I1 and I2, through the two resistors, but then they will again add up to give you I. So if I enters the junction, I leaves the junction. So that means whatever is the total amount of current entering the junction has to be equal to the total amount of current leaving the junction. So we will sum up all the currents that are entering on one side and sum up all the currents that are leaving the junction on the other side and equate them. And the second one, Kirchhoff's second law, we also relate it to conservation of energy. And Kirchhoff's second law states that in a complete loop, this is also called loop law because we talk about a loop, the sum of the EMFs in the loop is equal to the sum of the potential differences in the loop. So that means the sum of all the EMFs, that is summation of EMFs E, is equal to the sum of all the potential differences across the loop, that's product of I and R. So we have to see everything here in the form of a loop. So but you have to remember that what will be the sign convention that you need to take care of. So for the sign conventions, like when you're crossing, you're going from this side to this side. If you come across the negative terminal first and positive terminal later, like this you're going, then the EMF E will be positive. And if you traverse a circuit in such a manner that suppose you are traversing a circuit from this side, so the positive comes first and the negative comes later. So if you're traversing the circuit like this, I would say, so you go from here and then here, in this case your EMF will be considered as negative. And when you are traversing a circuit, when you come across the loop and you find that your product of IR, now you are traveling from left to right, the current is also traveling from left to right. So the product IR1 will be positive. And then we go from here. If you go here, now look, either you'll go up or you'll go down. So if you go down the loop, you are traveling in the same direction in which the current I3 is flowing. So your direction of traversing the circuit and the current direction, they both are same. So I3 R3, this product will be positive. But if you go from here, go up and go towards right, so now you are going to the right, you are traversing the loop to the right, but the current is moving to the left, so therefore the product I2 R2 would be negative. So it depends on in which direction you are traversing the loop and in which direction the current is flowing. So if both are same, the product IR would be positive. If they are opposite, the product IR would be negative. Okay, so let's have a look at this question. Calculate the currents in the circuit shown. So we are going to use Kirchhoff's first and second law both. First of all, let's apply the Kirchhoff's first law because the current I1 that is entering and passing through the 3 ohm resistor goes here and splits up into I2 and I3. So we will apply the equation that I1 is equal to I2 plus I3 as per the Kirchhoff's first law. Now, let's make the loops. The first loop we'll consider, I'll mark it as A, B, C, D, E, F, G, H. So in the loop A, B, C, D, E, F, G, H, A. That's the entire loop. That's your loop 1. In this loop, if we apply the Kirchhoff's second law, the sum of EMFs is equal to the sum of products of the potential differences, That would give us that sum of all the EMFs. There's just one cell, so the total EMF is 3 volt, and that is equal to the first potential drop across 3 ohms is IR1. So I1R1, that is I1 into 3, plus the second one happens here, I2 into 9. So I have the equation 3 is equal to 3I1. 3 is equal to 3I1 plus 9I2. That's the second equation. And if now we look at the loop 2, that is going to be this way. So in this loop, you are traveling from DC to FE. In the loop DCFE. So you go from left to right. So your product is 6I3. And when you go from here and you reach here, you are going to go from right to left, and the current I2 is coming from the front. So the product of I2 with 9 is going to be negative. The direction of current I2 is opposite to the direction in which you are traversing the circuit. So that's minus 9I2 is equal to sum of all the EMFs in the loop. There is no cell in the loop, so that is equal to 0. Okay, so now from here, this is your equation number 3. So what we can do is we can get rid of I3, because from equation 1, I3 can be written as I1 minus I2. So let's put up this value of I3 in the equation 3. So it becomes 6 times I3, that is I1 minus I2, minus 9I2 is equal to 0. So this gives me 6I1 minus 6I2 and minus 9I2. So minus 15I2 is equal to 0. So finally, we have these two equations to be solved. That is 3 is equal to 3I1 plus 9I2, and 6I1 minus 15I2 is equal to 0. That's equation number 4. So let's solve equation 2 and 4 as simultaneous equations. So when you will solve these simultaneous equations, you will get the values of I1 and I2 to be. So we get I1 to be 0.45 amperes and I3 to be 0.27 amperes. And so I2 is 0.18 amperes. So all we had to do was applying Kirchhoff's laws. We get 3 equations and we have 3 variables. So we are able to solve for I1, I2 and I3. So that's all in this video session. In the next video session, you are going to learn about the cells, the primary and the secondary cells, and the internal resistance of a cell. Thank you.